Okay, let's bring up our next speaker.
Please.
Very excited here. Who here uses Vim? Okay, who here uses vim-go? You owe this man a drink. He has helped us all out tremendously. His fun fact is hands down one of the most interesting fun facts I've ever heard. He was at the age of 14, right? 14, was awarded the President's Award from the President of Germany. Now he's Turkish, but he got the award from the President of Germany for his research into Nazis.
Yeah.
Wow.
Okay.
Right? So ladies and gentlemen, without further ado, Fatih Arslan.
Welcome, everybody. So my name is Fatih, and I'm working for DigitalOcean. And today I want to talk about how to write tools for Go code. So 1 year ago, I gave a talk in Paris about the state of Go tools, what we have, and what we can do with the Go tools. And we have so many amazing tools, but the question is always, how do we write them, right? And I wanted to write a tool myself, but I wasn't sure where to begin. It was really very hard, like limited documentation. And to be honest, I didn't know where to look. So after reading lots of documentation, code, whatever, I wrote a tool called Motion that is right now used inside Vim. And this tool has a couple of features that I always wanted to be. So you can, for example, jump to a function or type declaration, jump to the next function. You can select a function with comments, delete them, a lot of other features. And here's a demo of it, just as an example. So when I click on it, I'll write main, and my cursor jumps to main. And if I write again check, if it will jump to the check function declaration. So this is a very basic feature of Motion. And so how do we write this, right? So we have to start from the beginning. And I want to talk about the lexer and parser family a little bit. So I'm going to cover the token package, the scanner package, the ASD package, the parser package. No, it's not a Windows advertisement, and the printer package. So let's start with the token package. So the token package defines just constants, lots of constants, for the lexical tokens of the Go programming language. So it's just a categorization for the purpose of language, for the purpose of the parsing. And for example, what does this mean? And here, for example, we have some examples. So this means, hey, if I have two quotes and some characters between them, this is a string. If I have just a number, this is an integer. Or a float, this is a token.float. This is all constants. And we have multiple constants inside the token package. This is just some of them. We have special tokens, or some other like the right brace, semicolon, whatever. And the token is actually a very basic type. It's just a type of integer. And that's it. And here's another example, a variable declaration. And you see that each word or character belongs to a single token. So that's the token package. And the token package has also two other things. It includes a position-related type and a more compact and efficient of the upper position type. It just like shows us where the token is on which line, on which column. And we also have some types about handling files, like to track the positions of tokens. And the file set is just like if you have multiple files, you're going to use the file set type. So now, how do we get the tokens, right? By using the scanner. And so the scanner, also called lexer, just reads a slice of bytes and then gives you the tokens one by one. So here's a very simple example. This is our source code, and we're passing it to the scanner, and it gives us the tokens. And so how do we scan? So this is an example code. So basically, you just define a slice of bytes with your source code, and then you initialize the scanner, and you say, hey, I'm going to create a fake file and add this source, And hey, scanner, if you also see any comments, please scan them as well. And this is the signature. You call s.init. And once you call it, in a for loop, you can start scanning. And every time you call the scan method, it gives us a position, a token, and a literal. And we stop until we get the special token called EOF, end of line. And then we have to stop there. So here's a demo of it. We pass the source code to the scanner, and we call the scan method. We get the variable token. We call it again. We get the identifier for the sum. Again, we get the integer, equal, 3, plus, 2. And then finally, we get the end of line. And then we finish. And then we break. So the scanner finishes his job. So having all these tokens is really awesome, but we have to also get a meaning, like how do we know that this is a variable operation, right? So that's the question. And to answer this question, there's the AST package. And the AST package declares a lot of types to represent the syntax tree, the nodes of a syntax tree for Go packages. And I'm going to show an example of that just for a minute. This is very important, but not important for my talk right now. Every node is an interface, and it implements these two methods. The starting position of the node and the ending position. And this is not important for my talk, but will be later. So for example, here is an example of a very small expression, 3 plus 2. And you know these tokens, integer, add, and another int. So we can represent this in an AST with the binary expression. So as you see, this is a node because of these two methods. And what we're going to do is, hey, the left operand is the number 3. And the operator itself is the add operator. And then the right operand is actually an expression, but the 2 is just a number. So we just say, hey, this is the number 2. And then when you put them all together, you get the binary expression. So this tree is still not finished. We can represent the number 3 as a basic literal, and the number 2 as another basic literal. And if you combine them, you get this syntax tree for this very simple 3 plus 2. Here's another example. And as you see on the right side, 7 minus 5 is another binary expression. So the right side of the node is represented as a binary expression, as you see this part. So another example, our variable declaration. This can be represented by the type value spec. And I'll show you how we're going to do it. So basically, we're going to use the AST ident for the value name. And then the integer is the value type, is the AST ident. And the values of the value spec type is actually the expression we already knew. And if you put all of them together, this is now our AST for this very simple variable declaration. So now the question is, how do we get an AST? And how do we obtain it, right? So to get an AST, we need to parse. We need to implement a parser, and the Go parser does it for the Go source files. So here's an example. You just pass it to the Go parser, and it outputs the AST. But as you know, I showed it, inside the parser is using the scanner and the token constants. So the parser actually uses the scanner to get the tokens and then create the types for the AST. So the question, how do we parse? Here is another example. I defined a very simple source. And then I'll say, hey, use this fake file, and then parse it and give me back to the node. And this is of type ast.file, by the way, because we are parsing a file. And then finally, we are printing it to the standard output. We can print it in various ways. For this example, I'm going to use this ast fprint, which is actually just printing it in a very long way, like this is. But I've enhanced it for you. So this is an AST file, and you see the names, the declarations. Here, the declarations. types, the values, and many other things. And so if you see a very big output like this, the question comes, how am I going to traverse the tree? So if I want to find something. So let me explain this with an example. Let us find a line and column number, especially for this binary expression here. So again, we're going to define our source code. And we're going to say, hey, this is my source code, and I want to parse it. And then I'm passing it to the parser. It gives me an AST file. And then I'm starting to iterate over the top-level declarations. Here on the right side, I've just shown you the declarations, the top-level declarations, like the import declaration, function declaration. And what I'm looking for is actually a function declaration, okay? Because I want to go inside the main function. And once I have the main function, I'm iterating over the body. And every single line, there is a statement. But what I'm looking for is for a declaration, for a variable declaration, right? So first, I'm looking for a declaration statement type. Once I have it, I'm looking for a generic declaration. And every declaration in Go is represented by this type. And so this type has a slice of specs. And as you know, I showed that the variable declaration is being shown as a value spec. So once I have the value spec, I'm looking on the right operand, on the values side. And then I'm searching for the binary expression. And once I have the binary expression, I'm just printing it to the standard output. And we have it here. It's on line 6 and column 17. So this is a very tedious process, of course, like traversing all the tree one by one. Is there an easier way? Yes, there isn't. So we're going to use something called a function called AST inspect. And this function is really cool because what you do is you pass the root node, the file, for example, in our example, and then you're passing another visitor function. So when we call this function, it calls the visitor function for each of the nodes one by one. And this is how we then implement our previous example with AST inspect. We are going to write a visitor function, and we are going to say, hey, every time you visit a node, check if it's a binary expression. If yes, please print it to the output. So that's it. And here we see that's on line 6 and column 17. So I really like AST inspect. It's a really cool tool if you're like trying to traverse the AST. So finally, the Go printer is a package that prints the AST nodes in a human readable format, in Go format, actually. There is also a package called Go format, but I'm just showing this for now. So basically what you do is you're passing the Go AST to the Go printer, and then it prints it to the standard output, as you know, the Go file itself. So before I use AST fprint, which does very differently. And how do we print? Again, it's very simple. We first define our source, pass it to the parser, and once we get the node, we just pass it to the printer by calling the fprint function. And when we call it, you see the exact same source is printing to the standard output. So having all these tools is great, and so let's get back to the motion tool. So how do I write this motion tool, right? So I have some rules here, and so we're gonna first read it, inspect it, or navigate it, and then write it via Go printer to output, or we can write it in our own custom format, and then we're gonna create a CLI. So basically, I just created a new parser, a function that wraps the Go parser, which accepts some settings like, hey, I want to parse a file or directory or just the in-memory slice of bytes. And then I'm just parsing it and assigning it to some fields inside the parser, and then returning back. So now I parsed my Go source, and I have it inside the parser struct. Next, inspect. So in our case, we are jumping to the functions. So what we are going to do is we are going to collect all the functions inside a single file. So we name a function called collect functions, and then we define a slice of function declarations types. We are writing a visitor function, and we're going to say, for every single node you visit, please look for the function declaration, and then append it to the slice of functions. And then I'm calling the AST inspect function, which then collects, traverses all the nodes, and then collects all the function declarations from me, and then I'm returning the functions. So next step is writing it to the standard output. And for that, I just wrote a method called format functions, which accepts the slice of functions and returns a string. I create a buffer, and then I iterate over all functions. And I get the position, the function name, and then another, the signature, how it looks like, because we are going to use it inside an editor. And then for every single function, I'm doing it, and then I'm returning it back as a string. Finally, I'm creating a CLI. This is the CLI itself. I'm just defining two flags. One is the file flag to get the file name, and the mode, because Motion has a lot of modes, like looking for types, looking for functions. And then I'm just creating my parser. I'm passing my file to it. And then if the mode is functions, I'm calling collect functions, which collects all the functions. I format them, and then I print them to standard output. So here is an example file. And when I pass it to Motion, it gives me in this format. And then I just take it and put it inside the editor. I call it inside the editor, right? So this demo is the same demo I showed it in the beginning, right? And this is how you write a tool. So a very basic one. Let me show you another case study, everyone's favorite tool, Go format. And we're going to do the same methodology here. We're going to first read, inspect, write, and then create a CLI. So we have our unformatted source file here. We're going to pass it to the parser. This box, green box, represents the Go format, by the way, the source file. And then it's going to generate as an AST. And here is the code inside that I've just put it out from the Go format. So it just reads from the input. The function is called process file. And then it parses the source to the function called parse. So this is how it parses. And if you look at it, it's really very simple. And then finally, inspect. So the Go format has a couple of things. First, like it sorts the imports, but it also has two flags. Like it can rewrite some rules for you inside your source file, and also it can simplify the AST. So like in Motion, we collected the function, but in like Go format, there's entirely something different. So here is the part of the AST part inside the tool, inside Go format, and you'll see that. If I pass the rewrite flag, it rewrites it to node. The file is, by the way, this is of type, this is the AST type. And then it also sorts the imports. And then finally, it simplifies it, if also the simplify flag is passed. And finally, write it back. We are going to use the Go printer for it. And in Go printer, it's just going to print the simplified or rewritten or nothing back to the standard output. And here is the case for that part. It just have another wrapper called format inside Go format. It returns the result, and then it just prints it out to standard output. And finally, create a CLI. This is a very small excerpt from the Go format. It has a lot of ways to get the files. Like you can also pass the standard from standard input or multiple files. So it's important stuff is here, the process file, which I have shown you. And so basically, what you do is, I have a file here, and then you're just passing it to Go format, which passes this file to process file, and then goes over all the packages that I've just explained. So for recap, we have any kind of source, we pass it to the parser, and then which the parser uses the scanner and the token inside, but it's not important for us. We get the ASD, and then we do some great stuff on it. And then finally, we pass it to the printer, and then the printer prints it us back to anywhere, standard output. So what are the next steps? So we now know how to write a simple tool. So basically, I talked about this in the bottom here, about the parser family. And with this, you can write a tool like Go format or like a tool Motion. However, there are other packages for more advanced tool, like the type checker. And if you have the type checker, you can write a tool called something like vet or Go rename. And then for more advanced things, you can use the pointer package, the SSA package. This is renamed to Guru, by the way. This old slides. I've got it from Alan's one slide. I just copied it here. So, yeah, that's it. Thank you very much for listening.
Okay. I think we have time for a question. Any questions for Fatih? No? Come on. There we go, right back there.
Not so much on this specific, but can you tell us how you're using Go in the workplace?
How I use vim-go?
Or Go in general.
In Go, general, in DigitalOcean? Yeah. Oh, like we use it for all our services. We use it for our droplets, for our compute service, for our, we use Kubernetes. We wrote services on top of Kubernetes. That's all written in Go. Basically, pretty much all our services are written in Go. We have some Ruby, all Rails, I guess. But yeah, that's it. Yeah. You're welcome.
Hi. Did you have to do anything special to actually integrate it with Vim itself? So you wrote the CLI, but how do you actually kind of connect it with Vim?
Yeah, the motion tool is actually used inside Vim.
Yeah, he wants to know, what did you have to do to get Vim talking to the motion tool?
Oh, I just called the CLI itself. Like, I just run it inside the shell. And this is how like all editors do it. They call Go format and then like inside the editor and gets the output and then replaces the buffer inside the editor.
So Vim script is your answer.
Yeah, it's Vim script.
Vim script shelling out to the command.
Okay. I do it so you guys don't write Vim.
Exactly. Thank you very much, Fatih.
Yeah.